Okay, so we'll today first start with wave equation. After that, you have got something called wavefront, reflection, refraction. At that moment, I will just jump out. I will go to a little bit of light to explain you what is reflection, refraction. Then we will come back here and understand. Okay, chale, all fine? No issues? Chalo. So let's start now first with what we call as the wave equation. Wave equation. Pretty simple. Okay, this is pretty simple. The wave equation tells us that there are three parameters in a wave equation. The first parameter being the wavelength of the wave. Okay, the first parameter is the wavelength. Wavelength denoted by lambda. The next parameter is the frequency of the wave. Frequency, and frequency is denoted by f. Let's write their units also. Wavelength is in meters, frequency is in hertz. Hertz can also be written as second inverse. Have you understood these things? Ashmita, you understood the workout which I sent you? Okay, right. And the third, we will say what is known as the speed of the wave. Speed of the wave. So pretty simple. The speed of the wave we can take say as v. So v is given as the product of lambda cross frequency. V is given as the product of lambda cross frequency. So what is the unit of speed? Meter per second, right? Meter per second. So we'll check from here. Lambda has a unit of meter and frequency has a unit of second minus 1. So yes, we are getting a quantity which is speed. Right? When you do these problems, make sure that v speed of is always in meter per second. So you will be given some basic numericals where we have to play between these three figures. Right? Okay. This is a very, very interesting equation because this is a generic equation of a wave that I have put. But if you again look at the sun and you look at the sun's electromagnetic spectrum, so from the sun, whatever we are getting, the entire spectrum which is coming as a wave, we say that the speed of this is taken as c with the letter c, and it is again wavelength into frequency. Right? Now in this, what all we have? We have gamma rays, X-rays, ultraviolet, visible light, infrared, microwave, radio wave. Everything is coming with the same speed. And this speed for that of sun spectrum is 3 into 10 to the power 8 meters per second, which means if you are talking on cellular communication with someone, then the wave is coming at this speed. If you are watching Tata Sky, the wave is coming at this speed. If you are watching listening to radio, the wave is coming at this speed. If you are being hit with ultraviolet, the wave is coming with this speed. What are changing are these two. So just to give you an example, so how do you just take it as an example? Like 6 can be obtained as 1 into 6. 6 can be obtained as 6 into 1. 6 can be obtained as 2 into 3. 6 can be obtained as 3 into 2. Various different combinations. Are you understanding? So in fact, if you have a little bit of interest, I can post one picture. Like if you go on any radio station, so every radio station will have a frequency, whether it's BBC, whether it's Radio Australia, anything, they'll have a frequency and they'll have a wavelength. They'll always announce it. This is the BBC's radio service broadcasting on so and so frequency, so many meters. They'll say that is the call sign. You just multiply those two, you'll always get 2.99 into 10 to the power 8. Whether you are using All India Radio, you're using Tata Sky, anyone. Is this clear? So based on this, we will have some very kiddo problems. Let us do 1 or 2 problems, okay? Okay, you can take down. A wave is traveling at 5 cm per second, 5 cm per second, mind you. So when you get problems like this, what is our problem? The problem that we are getting, children, is like this. See, they say that the speed of the wave is given as 5 cm per second. I know you have a calculator, but try to use standard notation. Standard notation means 5 into 10 to the power minus 2 meters per second. This is easy to handle, the exponents, okay? And it has a frequency of 2 hertz. So we have a frequency, our frequency is 2 hertz, which means it is equal to 2 second inverse. So they have been asking you find the wavelength lambda. Can you calculate and see how much is the wavelength? Lambda would be equal to C over C is equal to, sorry, C means out here we are using V. So V would be equal to lambda multiplied by frequency. So our frequency is equal to V lambda. So it's 5 divided by 2, which should be 2.5. So our answer should be 2.5. Not, oh, again I'm writing everything wrong. No, we have been asked to find lambda, right? Yeah, so lambda is equal to V over F, which is equal to 2.5. V is this into 10 to the power minus 2 meters. Correct? Is it correct? Okay. 0.025. अब कैलकुलेटर नहीं चाहिए, कुछ कुछ चीजें बिना कैलकुलेटर भी कर सकते हैं. Okay, one more question. A wave is traveling at 5 cm per second, has a frequency of 50 hertz. You'll be able to do this now? Traveling at 50 hertz. We're just changing numbers. Let's take another question. A wave has a speed of 10 meters per second. Wavelength is 1 meter. Speed is 10 meters per second. Speed is 10 meters per second. Okay. And the wavelength is 25 centimeter. Calculate frequency. Always girls, I can say girls today, there's no boys. There are no boys. Okay. Always have your eyes fed on the unit. These are easy problems. So the way they will like to get you wrong, they want you to get it wrong, right? That is with units. If you look at the problem now, the speed is in meters per second. How much? 10 meters per. However, the wavelength is in centimeters, 25 centimeters. So how do you write it? 25 into 10 inverse 2 meters. Calculate the frequency. Okay. The next problem, okay. Speed is how much? 10 meters per second. So our speed of the wave is 10 meters per second. Shrenika, dekho, koi tension nahi hai. Lambda is how much? Lambda is given as 25 centimeters. So centimeters mane 2 ghar. That means 25 into 10 to the power minus 2 what? Meters. Now I need to find out what is the frequency. The frequency is always V by lambda. So V means how much? V is 10. 10 divided by 25. And this 25 is into 10 to the power minus 2. So straight away 10 to the power minus 2 can go up and it becomes 10 to the power 2. 25 4s are 100. So this becomes how much? 0.4. And this is hertz. Now if you want to better it, it will be 4 into 10 to the power 1, which is equal to 40 hertz. नहीं चाहिए कैलकुलेटर, आप ऐसे भी कर सकते. When I say nahi chahiye, she gives you a look to me. Okay. Okay. Our next section talks about things like wavefronts and all. So we'll just discuss what is a wavefront, and then we'll immediately go to light. Once you understand the concept in light, it will be very easy to understand here. Done, all of you? Where did Ahiri get disappeared suddenly? Not. Oh, she has a power cut. Okay. So let's go again. Now the next topic that we need to understand is, what do we understand by a wavefront? Wavefront. Just understand it conceptually. Let us say that there is a source. This is a source. Now when you are studying waves, as I told you, waves is a phenomena. Waves can be studied for sound. Waves can be studied for light also. That's why your next chapters are all dealing in optics. So we will study something in light. It is easy to understand there, and then we'll come back here. So if you have a source, say if you're studying optics, then this source is a bulb. If you are studying acoustics, then this source is something which is making a noise. At the end of the day, all we are interested is wave. This source is emitting waves like this. Understood? Right. Please understand it very nicely. Right now, there is a wave getting out from me. It is not one wave which goes out. There can be two waves which are going out from me. So I'm trying to draw those two waves. And there can be many waves, not only two, there can be many waves. Do you understand this? I am a source and I am rolling out waves. At this time, what do? We create a surface which is like touching all points in the same phase. So let's say that there is a wave which is going out from my, say, left side of my mouth, and there's a wave which is going out from the right side of my mouth. I want to touch the 2 points which are on the same phase. Now there can be many such points, 2 points on the trough, 2 points on the crest, 2 points which are going up, 2 points which are coming down. The easiest way for us would be to understand that let's pick those points as 2 points on the crest. Do you understand? थोड़ा mismatch हो गया drawing, so it's like this. Like this, it's 2 points. I don't draw this, okay? I hope. Is this much clear? Have you understood this? This surface, okay, this surface, which is actually comprising of, this is a flat, it's an imaginary surface, or you can say it's a line, which is actually comprising of all the points on the same phase. These are known as my wavefronts. Wavefront. So this is a wavefront, this is a wavefront, this is a wavefront. समझना बहुत जरूरी है, समझे हो तो ही हाँ बोलो. Have you understood? So let's say there are 9 waves. Just imagine, have you seen swimming in Olympics and all? So there are 9 lanes in the swimming pool. From each lane there is a wave, all right? And this is my swimming pool. You all are on the other side, on the length side, I'm on the other side. So we keep a stick in which the wave is going. We just keep the stick on the crest of all the 7. That is one wavefront. This wavefront is keeping on traveling. When you see the wave going, how do you see the wave going? The crest keeps on traveling, the trough keeps on traveling, every point. Now we are interested of all points which are on the same phase. So there can be many such combinations. The easiest way to understand is, sir, put that imaginary line on the crest of lane 1, crest of lane 2, crest of lane 3. So I get a straight line, and that line slowly keeps traveling. Have you understood? Right? And when this line starts traveling, then what I do, I can create what is known as, I can create something which is known as, which is, say, perpendicular to this wavefront. Do you understand? Perpendicular to this wavefront. This is the direction of the wave. And if we now change our topic to optics, if we change our topic to optics now, that is, if we now diverge to light, and I say this is my light source, this is my light source, then this is, children, what is called the imaginary concept of a ray. This is your ray. How does the ray of light, how does the ray travel? The ray travels perpendicular to the wavefronts. So let us understand once again, if we have a little bit of query also. So let's say I have a bulb out here. Now this is a light source. This is a bulb. And we call this, in a higher grade, we call this as a coherent source. Okay. Now this bulb must be sending waves from it, because light is also a wave. This is one wave. This is another wave. This is another wave. I am interested in knowing what are the wavefronts. So what I do, the wavefronts are all the points which are on the same phase. It joins. So this is one way. See, if you're dealing with crest, please stick to crest. If you want to stick to trough, you can stick to trough. So the wavefronts will be all parallel lines like this. And the beauty of these wavefronts are what? The beauty of these wavefronts are, they are the line that join all the points which are on the same phase. Samajh mein aaya? So the greens are known as the wavefront. Wavefront. And now if I can construct something that is, perpendicular to the wavefront, this is what we generally get interested and say that this is the light ray. All of you understood this? This is the light ray. Now, before going more into what is called reflection, refraction, diffraction in waves, we will now straight away go to light. Light में सब कुछ समझना आसान है, and then we'll come back here and you'll say, sir, ये तो easy है, आगे बढ़ो. Clear? Okay. One small discussion which I'll still keep you posted about is, let's say I have got a flat surface. Flat surface means, imagine that this is something like a, not a micro ball, but a micro dish, you know, the micro dish. Sometimes we also cook in a micro dish. It's a big dish, not a ball. So this dish is filled with water. This is a microwave dish. This is a micro dish, and the dish is filled with water. If you take a point object, it can be your finger, it can be a stone, and if you drop it vertically from top on that particular thing, what you will observe is circular ripples being made. Circular ripples. So when are circular ripples made? Circular ripples are made when point object strikes this particular water surface. So if you drop it once, you will see the ripples just created and then just vanish. No, sir, I want to see the ripples continuously getting out. So give it a motorized motion where something will just go in, come out, go in, come out. So you'll see the ripples coming out. Have you understood? The same sort of a microwave plate or a dish if we take, and this time instead of a point source, you try to put a flat surface. The best example is your wooden ruler, the ruler that we have, and you just put the ruler once in and you take it out, you will find that the wave fronts are like ऐसे करके जा रहे. These are the wave fronts, ऐसे जाएगा. And if you want them to be continuous, then what do? You just have a mechanized motion in which that ruler will go down and go up, go down and go up. So you will see the wave fronts. These wave fronts, these are actually wave fronts. In a ripple, what happens? The water is coming up all at a time on the top. So those are a wave front. Don't you think? All these points can be joined together. This is a wave front. Similarly, these are also wave fronts. All points which are on crest have all come up together. So you see a straight bar. If you are seeing from the top, right? And if you go on moving that scale inside, dip in and dip out, dip in and dip out, you see the wave fronts are getting created. What you should remember is circular wave fronts are made by point objects. Straight wave fronts are made by flat objects. This will be created by a flat object. This will be created by a point object. A very best example is this can be a stone or a pebble, and in this case we will use our ruler. Have you understood this? We will not concentrate on the diffraction of with wave fronts and all as of now. We go back to light, a little bit of light. Ready? Wavefront clear? Chalo. अब light में चलते हैं. So some brief things about light first. Light. Okay. So one of the questions that we always try to answer is, how do you see objects? How do you see objects? So I always say, to see objects you need three things. One, a source of light. एक source of light चाहिए. Okay. Number two, what do you need? You need the object, obviously. And third, you will need an observer, that is you yourself. These three are the first basic requirements to see an object. So let's try to see an object. Let's say that we have got a lovely flower out here. Okay, this is our flower. ये हमारा flower है. Yeah, this is a flower. And there is an observer. There is an observer out here, and the observer is interested to see this flower. The way that we see this, we need now a source also. So the source can be two things. Say, let's say we have sun as a source, or we can also have, say if it is night, then we can also have a bulb as a source. Okay. Now, what is the funda in which you see something? The way we see something is light ray from the source should strike the object. Okay. Light ray from the source should strike the object, and then this light ray should get reflected back to the observer's eye. If this condition is met, I can see an object. If this condition is not met, I cannot see an object. Now let's see. The flower vase is right in front of me. There is a light source. The light is coming on my eyes. I can see you. Now, let's say the flower vase is right behind me. Okay, ऐसा कर देते हैं ना, ऐसे ले आते हैं. Let's say the flower vase is right behind me. ऐसे यहाँ पे पीछे ले आओ ना. Now we will say that we will not be able to see this, but there can be some way in which we can be able to see this also. Let's say in this condition we create something like this. Let's say we put up a mirror out here. यहाँ पे एक mirror डाल देते हैं. Okay, we have a plain mirror out here. And now how do we see this object? Light ray from the sun comes here. Understood, sir. And then it goes and falls on this mirror. And then it again comes back to my eyes. In this case also, I'll be able to see. Just like you two girls right behind me, I should not be able to see, but this is some sort of a reflective surface. So I can see at least that you two are seated behind me. So if this condition is not met, we can't see. So human beings can see up to, they say that there are some animals who have got 360 vision. We do not have. Nowadays, like televisions, they say this television has got almost 157 degrees OLED vision, which means what? If you are watching the TV from here also, you should be able to see it properly. That's those are the costly TVs which are there. Is this criteria understood? Okay. The next topic that we will discuss here is that when you talk about the source of light, this source can be classified into two heads. We call them luminous and non-luminous. I hope you know about them. Luminous are those bodies which produce light on their own, like the sun. The sun is a luminous source. The stars are luminous. The planets are not luminous. The moon is not luminous. Do you get it? The moon reflects the sunlight. And an example of an electric bulb is very stylish. An electric bulb is non-luminous, but however, when it glows, it is luminous. So whenever you give the example of an electric bulb, you should be very careful where you are placing it. An electric bulb when turned off is non-luminous. An electric bulb when turned on is luminous. Fireflies are luminous sources. Clear? So ये हो गया. और एक classification भी हम करते हैं, that is on this object. I don't know whether it's there in your book or not, but from basic you should know. Objects can be transparent. Transparent means these are those objects which allow light to completely pass through them. Then we have something called translucent. Partially allow, like butter paper, frosted glass, bathroom glasses and all, those are called translucent. And which do not allow light to pass at all are called opaque objects. Clear? Transparent, translucent, and opaque. Okay. Very good. Our next topic of discussion would be reflection of light. Reflection. In fact, a lot of second chapter we are doing here, reflection of light. First, let us understand, then we'll go by the definition, okay? Suppose we have a surface, okay? We have a surface, like say this is a surface, right? In optics, we have a thing which, a term that we use, which we call as medium. Medium is the environment through which light is traveling. So when sun comes and hits your body, the medium is what? Air. First, it will be vacuum or no air, that is the space portion. Then it enters the atmosphere, which is air. So air is one of the medium, okay? Air can be a medium. You're inside a swimming pool, then water is the medium. You're inside a glycerin tank, then glycerin is the medium. So if light rays from a source, okay? So whenever light rays are coming and striking any surface, okay? So we'll call this as a, I'm calling this as a surface. And this is my light ray, right? So this ray which is coming, light ray comes, so we call this as a incident ray. And the language we use is, when light rays are incident on a surface, then a phenomenon of reflection always happens. What is reflection? That the light rays are sent back to the same medium from which they came. ये होता ही होता है. किसी में ज्यादा होता है, कोई सरफेस में कम होता है, right? This phenomenon is known as reflection at a very crude point. So how do I define it? I say reflection is the phenomenon due to which a light ray which is incident on a surface is sent back to the same medium or reflected back to the same medium. In such a case, I would call this ray as the reflected ray. Sir, do you mean to say that 100% of the rays which come, and okay, first of all, understand children, ray itself is ray is an imaginary concept. Ray concept has been done to understand the geometry of optics. Otherwise, we won't be able to make images, right? So what is a ray? A ray is typically similarly like our vector. So we show our ray like this. The arrow shows where it is heading to, and the tail shows where it is coming from. This is one ray, okay? And if this is another, and similarly, if you make a collection of such rays, then this will be known as a beam. One stick of a broom is a stick. Many sticks together is a broom. Jharu ka ek strand and many strand. One strand is a ray. So this is known as my reflected ray. So what do you understand by reflection? The phenomenon due to which light rays which are incident on a surface are sent back to the same medium from which they came. Now question arises, sir, does 100% of the light ray gets reflected? Well, I don't know. It depends upon the property of this surface. If this surface is such that it is able to reflect not major, maximum portion, always there will be some absorption. Whenever light hits a surface, please ye jaan ke rakhiye, suppose this is light and light comes and hits a surface. Light comes and hits a surface. This is a light. Okay. Three things will happen. One is called reflection. Okay. Number two, there will be a refraction also. Now this will say maybe there will be absorption also. थोड़ा सा light तो absorb भी करेगा, थोड़ा सा reflect करेगा. Now if someone is there who is reflecting major part, then such a surface will be known as a reflective surface. Reflective surface. And the best reflective surface that is known to us, or the best material for reflection, is silver. Always remember, silver is the best reflector. That's why all these satellites which run maximum on solar cells and all, they always have a lot of silver work on them. Silver is one of the best reflector. So all the studies that we will do right now, we can't take silver. So we take an analogous to silver, which you see in the washroom basin where you brush your teeth every day in the morning. That's what we call as a plane mirror. What do we call it? Observe the spelling. It's not P-L-A-I-N. Plane dosa nahi hai. Plane mirror means it's a plane. Wherever you hold the mirror, there's a plane. So we call it a plane mirror, not plane mirror. Okay. So the analogous to it is a plane mirror. Okay. Little bit of basics. Sir, how is a plane mirror made? Very simple and very easy. Let's see how a plane mirror is made. In order to make a plane mirror, you need a piece of glass which is very, very thin, something around say 2 mm, 3 mm or 5 mm glass, pure glass. This is a see-through glass. This is a see-through glass, right? Okay. What do I do after that? After that, on this glass, what I'll do, I will put up what is known as, this is the cost addition part, the shiny surface, which is almost like a foil. Have you seen any of those mirrors on the washing or on the wash basin and all, where the mirrors have become old? And if you see on the corners, you will see something like foils coming out, and it has almost become a little bit like glass. So cost of the mirror depends upon what is that quality of the foil. Like you have mirrors like Saint Gobain mirror. Okay, they're very costly. Modi glass. So those glasses use very high quality reflective surface. In fact, if silver foil is used, it's excellent. So now this is a very, very thin foil, very thin foil. So in order to safeguard this thin foil, we will have another layer, and that layer is made up of a paint which is called the red oxide paint. So if you take any mirror and you turn the mirror back, you will see a red oxide paint. So the red oxide paint, red oxide is like what we put on before anything that rusts, you know. So to prevent from rusting, the iron objects are always coated with red oxide. So once you put red oxide on this, then it has become my lovely mirror. This is called a plane mirror. Now, once this has become a plane mirror, this surface, okay, which surface beta? This particular surface, that is, yeah, that is this surface, sorry, that is this surface. This is my reflecting surface, but in optics we will call this surface as, our polished side, or what we'll call it as smooth side. In other ways, if you want to understand, every morning when you stand in front of the mirror, you are basically standing on this side. You stand on this side of the mirror. Now, we can't draw this diagram every time, so we need a schematic representation of a plane mirror. A plane mirror is shown in this manner, a straight bar like this, and on the back side we will show etching. This is called etched. Okay, once you have etched it, this is the rough side. Rough side means the red oxide side, and this is known as my smooth side. Clear? Plane mirror. And for reflection, we have to use a reflective surface in all our discussions, so we will be always using this plane mirror, right? So reflection as a definition understood, right? And then you have understood what is incident ray. थोड़ा थोड़ा समझ में आया. और जहां पे आके ये गिरता है ना, जहां पे आके गिरता है, that particular point, this particular point is called point of incidence. Point of incidence. Okay, so you have an incident ray, you have a reflected ray, you should know the medium, you have a reflective surface, and this. Shall we go ahead now? Okay, so time now for us to understand the thing which is called laws of reflection. Laws of reflection. And from here we will take one step, dive back and go back to waves and wavefront again. Now it will be easy for you to understand. So what is laws of reflection? In order to understand laws of reflection, we first need to make the diagram that actually explains laws of reflection. So first make your plane mirror. Okay, tera hua hai. So this is my plane mirror. Right? Okay. On this plane mirror, we will first make an incident ray, a ray which has come and struck this. Okay, so let's name it. Let Mn be my plane mirror. Okay, and I need to make an incident ray. So this is my incident ray. Okay, this is my incident ray. I need to show it with an arrow that this is the incident ray. So let's call AO as my incident ray, and let's start labeling out here. Mn is my plane mirror. Very good. Then AO is my incident ray. Fine. AO is my incident ray. Then what does O become? O becomes point of incidence. At point of incidence, we will always construct a perpendicular at the point of incidence. Now we will construct a perpendicular at the point of incidence. Okay, so let's take a perpendicular here right at the point of incidence. This one. So this was O, and I call this as my N dash. N dash. So what is N dash? N dash is known as my normal. Normal means always 90 degree. Normal at point of incidence. Okay? Normal at point of incidence. The angle that the incident ray makes with the normal is quoted as I, and I is said to be, okay, I'll not mutate the diagram here. I is the angle between normal and point of incidence. Be very careful. बहुत सारा बच्चा क्या गलती करेगा पता है? In problems and all, see, they'll give you this angle, 30 degree. No, angle of incidence is 60 degree. Because angle of incidence is always angle made with the normal with the incident ray, not with the surface. So I will be known as angle of incidence, angle of incidence, which we say angle between incident ray and normal at point of incidence. I'll not write this again for the angle of reflection, but it. Okay. Now we need to make our reflected ray. So I'll use a different color for the reflected ray. So this is OB. So OB is my reflected ray. And the angle made with the reflected ray and the normal is called the angle of reflection. R is equal to angle of reflection. भाई साहब समझ में आया आपको? ठीक है? This is reflection which is happening at a reflecting plane mirror or a reflecting surface. Now we need to understand what are the laws of reflection. So we have two laws here. The first law is very easy. It says that the angle of incidence is equal to the angle of reflection. Okay. Angle of incidence is equal to angle of reflection. Right? What are we studying? Reflection. We are studying reflection with the aid of what, beta? We are studying reflection with the aid of optics. We are studying from light. Light is a wave, right? So here is where we will be slowly doing a handshake with the previous chapter. Why I made this for you? So that you get to understand this chapter also and the previous one more clearly. Law of reflection, you are seeing this laws of reflection of light. This holds very good as law of reflection for wave also. Are you understanding? For wave also. So if I have an incident wave, the angle that the incident wave does not have an angle, sir. How to make an angle, that we will see. But try to understand, the angle of incidence for a wave should also be equal to the angle of reflection. Means this principle holds for light. Should it hold for sound? Yes, sound is also a wave. समझ में आ रहा है? But for the chapter of light, we will say the incident ray, the angle of incidence is equal to the angle of reflection. But they all come from the same family of waves. अगर ये light के लिए valid है, ये sound के लिए भी valid है. मतलब पहला वाला chapter क्या था? The first chapter was all about waves. That was the master chapter. So we have to study this thing in the master chapter also. I brought you here because it makes you easy to understand. There is a second law, and the second law, children usually find it difficult to understand, but it's easy. The incident ray, the reflected ray, and the normal all lie on the same plane. Now, whether you are in CBSE, ICSE, anywhere, children just mug up this statement. They don't understand. What do we understand by all lie on the same plane? Let us understand what do we mean by all lie on the same plane. Okay. Let's say we take two vectors. These are two vectors. Whatever angle they may be, or two rays, right? Are two rays coplanar? Coplanar means coplanar. Coplanar means, can two rays share the same plane? Two rays can be in any orientation. सेम प्लेन में है कि नहीं जानने के लिए एक किताब चिपकाइए पीछे, चिपक जाएगा ना, कैसे भी ओरिएंटेशन में रहे चिपक जाएगा. ऐसे रखो तो ऐसे चिपका दो. So two rays are always coplanar by default. Are you understanding? Now let me say that I have got three rays with me. Okay, I have got three. Yeah. You didn't understand? Okay. Coplanar. What do you mean by coplanar? Okay. Coplanar means, think of a plane. Is this photo frame a plane? Yes. Can two rays be made to be sit in such a manner that they just sit on the surface of this?
Yeah.
So these two are coplanar. Now you may say with me, sir, you made a specific arrangement so it became coplanar. ऐसा कुछ नहीं है. आप कैसे भी रखो. सर मैं ऐसे ऊपर रखना चाहता हूँ, फिर भी आप चिपका सकते हो.
Okay, sir.
कैसे भी रखो. So दो में तो हमेशा coplanar होगा. अब तीन की बारी. If you make them like the tripod of a camera now, can you now have a plane which can touch all the three? No. So three में coplanarity का एक ही criteria है, but however if the three are like this, now can I chipkify one surface? Yes. This is what they are trying to say. The incident ray, the normal and the reflected ray are coplanar. Please children understand, it does not mean that they should be falling exactly perpendicular on the mirror. No, they may come and fall ऐसे टेढ़ा होके भी गिर सकता है. But they should be coplanar. Did you understand what I'm trying to say? Suppose this is my mirror. You might think that, sir, the three rays always come and hit this surface like this. No, not like that. They may come inclined also. When they come inclined, make sure they are coplanar. They cannot come like the legs of a tripod. Does it make sense? Okay. So this is my second law of reflection. The incident ray, the reflected ray, and the normal all are lie on the same plane. Have we understood this? At this stage, I will break and go back to waves now. Okay, let's go back to waves and see whether you are able to understand or not. Let's try to understand the same reflection phenomena now from waves perspective. Okay, so let me take a surface. Let's say this is my surface, right? And what do I say? Waves are coming. So how does waves come? Wave come in the form of wavefront. So I should have incident wavefronts. So how are the incident wavefronts like? Parallel wavefronts. समझ में आ रहा है बच्चा? These are the incident wavefronts. And how is the ray for it? The rays are always, you got it, na? मजा आ गया ना अभी समझ में? I can understand that. And the ray is always perpendicular to the wavefront. Now that chapter becomes clear. So these are my incident wavefronts which are coming and striking this surface. And the direction is always known by the perpendicular. So if this was a sound wave, this is the incident, but I do not say incident ray in sound wave. Isliye optics is the best to understand, the incident ray. And then we will get what? Sir, then we will get a normal at the point of incidence we should have. So let's make the normal at the point of incidence. This became abnormal, huh? So now this is my normal at the point of incidence. And now I should be generating my reflected wavefronts. Huh? And do we satisfy the law of reflection here? Yes. The angle of incidence I is equal to the angle of reflection. Few things we should know out here. If it is coming from a single coherent source, say suppose it is coming from a single source. Why do we use single source? Because this particular wavefront which is coming, it will follow the wave equation. V is equal to lambda into F, right? The F is always dependent on the source. रास्ते में धक्का खाए नहीं खाए, the frequency always depends on the source. Frequency remains constant. So when we study refraction, you will study that if there is an up and down on this particular speed, the only thing that will do an up and down is the wavelength. Frequency remains same. That's why I didn't use two sources. Two sources only say the frequency will be a mixed. Like say I am making a noise. Na 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 na. It's repeating periodic. There is a frequency. To whatever distance you are hearing me, my frequency does not change. strike करके भी जा रहा है तो sir, when you said it from your mouth, it was na frequency was say 3 hertz. By the time it is going to Srinika's ears, it is striking everywhere. It will be still 3 hertz. Until I start doing na 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 na. If I change, then only free. So frequency a question आता है 1 mark. Frequency always depends on the source. As long as you don't change the source, the frequency does not change. ठीक है? So have you understood now the reflection part from the wavefront? Clear? Okay. Now, when we see these wavefronts, okay, when you see these wavefronts, these are basically what is the wavefront? What is this stick? This stick is joining all the crests, all the crest, all the crest, or say all the trough, 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 all the trough. So that means it is the distance between two adjacent crests or two adjacent trough. Furthermore, I will say it is the distance between 2 points on the same face, very adjacent 2 points on the same face. Do you agree? Let's go back and see our diagram. This diagram. These lines are actually the distance between 2 points. We can also say 2 points on crest, 2 adjacent points on crest. And whenever you say 2 adjacent point on crest के बीच का distance, बच्चा ये distance क्या होता है? खुद ही बोलो आप. This is nothing but the wavelength. Yes or no? So if I go back to my diagram now, if I go, yes. So if I go back to my diagram, so this particular, okay, 1 minute. This particular distance represents lambda. Clear? Okay. Now I'm drawing some wavefronts and you tell me. Okay, I'm drawing some wavefront. Imagine that they are equidistant, okay? Pardon my drawing. Imagine that they are equidistant. These are wavefronts that we are receiving from two different sources, which are of shorter wavelength, which are of larger wavelength. This is A, this is B. But B is shorter wavelength. अभी समझ में आ रहा है? B is shorter wavelength, A is larger wavelength. Now I have a different scenario. I say that this is the wavefront which is coming from the same source, right? For interest लीजिए अभी है. This is the wavefront which is coming from the same source S. It initially came like this, and then suddenly became like this. Don't you agree? रास्ते में कुछ हुआ होगा, right? कुछ हुआ होगा. So this is coming with some speed which is say v, and initially the wavelength is say lambda 1. And I told you, as long as I don't change the source, what does not change? Frequency does not change. So in this case the frequency is f, in this case also f, but the lambda is lambda 2. Do you agree? तो आप खुद ही सोचो, पहले ये v1 velocity से आ रहा था, which was lambda 1 into f. Now its speed is what, beta? v2, which has become lambda 2 into f. Can you now tell me what is the relation between v1 and v2? Not proportional. What is the relation? Who is more and who is less? v2 cannot be more. v1 is, both have f as common. When the wavelength becomes shorter, the speed has to fall. हमें जानना पड़ेगा. Well, provided you are analyzing the same wave. Okay, so I'm not saying what happened in between. Something happened in between that I'm keeping as a surprise item as of now. So I say that if the lambda falls, okay, then the v has to fall. Provided you are analyzing this for same source and same wavefront, but in between these two some incident happened that I'm keeping as a surprise item as of now. Some incident happened, otherwise why did its wavelength become shorter? Have you understood? तो आपने एक चीज क्या सीखा, यहां पे आपको जो टेक अवे वर्ड है ना, योर टेक अवे वर्ड इज दिस, इफ स्पीड फॉल्स v falls, lambda falls. Remember that. For the same source. Now don't tell me that this wavefront came from sun and this one came from Jupiter. No, 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 no. They should come from the same source. If speed falls, what falls beta? Speed गिरने से lambda falls. Other way, if I say if lambda falls, speed should fall. Provided frequency is same. And frequency can be same only when source is same. I am the same person. That frequency is same. But आगे चल के इसका वेलोसिटी गिर गया, ये वेव का मतलब ये वेव को जितना दूर जाना था उतना दूर नहीं गया, तो हम क्या बोलते हैं, सर इसका वेवलेंथ भी गिर गया. ठीक है. Again we move back to optics. So we have cleaned one part because we have reflection, diffraction also. थोड़ा सा 5 minutes. Okay, 5 minutes. Next is the study, and then don't think I'll again teach reflection. Huh? I'm covering reflection and this together so that it becomes a story. And you always see your textbook, whether if anything is left. Refraction. Let us understand refraction now. In order to understand refraction, you have to always understand that refraction होने के लिए दो चीज चाहिए, तीन चीज चाहिए. तीन नहीं, पहले तो दो लिख लेते हैं. Okay. Mandatory. You need to have an interface. Now what is an interface? Interface के लिए लिखेंगे interface between two medium. Wow. Reflection में पूरा कहानी एक मीडियम में हो रहा था. It was happening from air to air. Now you need two mediums. So please understand. First, try to understand what does two medium what I'm trying to explain by two medium. It's something like yeah, air and water हो सकता है, but let's understand it diagrammatically also. This is two medium. Medium 1 and this is medium 2, right? And everything that is of your interest of refraction इधर पे होता है. This is the LOC, line of control, which I'll call as my interface. समझ में आया? Refraction होने के लिए there has to be an interface. Means refraction cannot happen in one medium. Me seeing you, there is no refraction. Bring the bottle between you and me, and now me seeing you and you seeing me, our faces, then there is refraction. ठीक है? So refraction क्या होता है? पहले basic समझते हैं. Basic मतलब just another 2 minutes. So let's say if I take an incident ray, now where it goes, where that doesn't go, I don't know, but I'm just drawing it arbitrarily now, and it's like this. Say I have an incident ray which has struck this surface, right? I have an incident ray which has struck this surface, and I used to tell you, right, that there will always be reflection, there will be reflection, there will be absorption. Refraction means you are allowing the ray to pass through you. This we also call as transmission. आप अपने अंदर से जाने दे रहे हो. तो मेरा ये सोच रहेगा कि my ray should have gone in this manner, है ना, ऐसा जाना चाहिए था, right? This is course of path. But what I will observe is that ये ऐसा नहीं जाएगा, ये ऐसा नहीं जाएगा, ये कैसा जाएगा, ये bend हो जाएगा. अब मुझे पता नहीं, एक ऑप्शन ये भी हो सकता है, एक ऑप्शन ये भी हो सकता है. I don't know which option it will pick up, but there will be bending. Either it may be one or it may be two. One or two. We don't know which one right now. So time now to define refraction. So the kiddo 8th grade or 7th grade definition first. Refraction is the bending of light as it travels from one medium to another medium. Very kiddo level definition. Refraction is the bending of light as it travels from one medium to another medium. Can we make it a little bit better? Refraction is the bending of light at the interface of two mediums. Always at the interface. ये बाकी कहीं bend नहीं होगा. जरा यहाँ पे गौर से देखिए. Look at medium 1. It came unbent. Every ghapla happened here. And again, here also, once it has been passed through, it is not bending. but the bending happens at the interface. So we'll stop here today. Refraction is the phenomenon of bending of light as it travels from one medium to another medium. Such bending is observed only at the interface of two mediums. At the interface of two medium. यही बुरा लगता है. I know you all are tired, but now I feel like another 2 hours I can run with this class. And you feel like, why don't we put some acid on your face, sir? I understand. But stopping something here is like, you watch those series and web series and something, and then suddenly he cites who is the fugitive, and next series coming 2026. And it never comes after that. तो यहाँ पे रोकने में बहुत दुख होता है. ठीक है, इतना करके रख देते हैं. अगले क्लास में इससे आगे जाएंगे. So reflection हमने कवर किया है. So we need to cover refraction from wavefront, refraction from light, and then diffraction. 2 चैप्टर एक साथ खत्म हो गए.
More dense.
Less dense and more dense, all those you need not remember. I'll give you such. If you are so interested, then there is a video which is uploaded for grade 8 basics. Grade 8 basics of refraction. Just watch that video. You watch that video, grade 8 basics. Then there are some lovely examples, the way we handle it with them. Okay. So